everyone, welcome to Riot's Lunch and Learn series, the place where we spotlight Riot's sponsors and partners. My name is Jen Morgan, and I'm the Virginia Program Lead with Riot. Just a couple of quick reminders before we get started today. This event is being recorded and will be posted to Riot's YouTube channels and the meetup pages where you registered for the event originally. If you have any questions throughout the presentation, please place them in the chat. We ask that you please place your questions in the chat so that they can be read aloud for those watching the presentation at a later time. All questions will be read throughout the presentation as they come up, and we may save some for the end as well. Finally, please keep yourself muted throughout the presentation for any background noise. Today, we have Helmut Lord and Wes Cherry with Nordic Semiconductor presenting Redefining Bluetooth Low Energy with the nRF54 series. Helmut and Wes, I'll turn it over to you all.
Thanks, Jennifer. Yeah, so my name is Helmut Lord. I'm the field application engineer for the Southeast. So that's everywhere from Alabama up to North Carolina. I'm based in the Atlanta area, and I've been with Nordic since April of this year.
Hello, I'm Wes Cherry. I'm a field applications engineer as well. I live in Philadelphia, but I cover most of the Mid-Atlantic and Midwest out to Michigan area. I've been with Nordic for 3.5 years now.
So today we're going to be discussing, as Jennifer introduced, our 4th generation series of SoCs. This is for short range, so 2.4 gigahertz, BLE, that sort of thing. So yeah, we like to say that we're raising the bar once again from our 51 series several years ago to the 52 series. It's bread and butter. That series has seen a lot of use in all kinds of products and is really a huge share of the Bluetooth Low Energy market. We also had the 53 series, which was intended to be a larger series of parts, but because of COVID and issues with supply chain, the only part in that series is the 5340, which is our first dual core part. During COVID, the company reevaluated and saw the issues with the supply chain and decided we were going to go full bore and start working on future generation parts. So that has led to the 54 series. So the cornerstones of the 54 series are an increased performance and lower power consumption. Nordic has always been great on power consumption. Our 52 series devices get into the single microamp sleep with RAM retention current. So we are in the same spot we are, but with even higher performance now with the 54 series, both branches of the 54 series. The 54 series, as opposed to our previous generations of products, will also be based on the 22 nanometer process at a number of different foundries. So we are diversifying where the chips are produced, not just from a foundry perspective, from a geographic perspective as well. So the 54H series, which I'll share here in a moment, is produced at global foundries in Germany, while the 54L series will be produced at TSMC, which is of course in Taiwan. We're trying to lead the way with IoT security. So there are advanced security services on device with protection from physical and side channel attacks. The voltage glitching attacks from years prior have been patched, and we've designed these parts for PSA level 3 certification, which is starting to become a bigger thing, especially in the EU. We're seeing more regulatory, people looking at that from a regulatory perspective in Europe. This is our 4th generation radio, and I'll share some more specifics about that radio here in a moment. But with that radio, you'll be able to use the stacks that you're familiar with, the protocols you're familiar with. So that's BLE audio, which is becoming a bigger thing, and that's one of Wes's areas of specialty. So if you have questions about LE audio, you can direct them toward Wes. But also BLE mesh, something more new that you may have heard of, which has come out of a sort of consortium between some of the big tech companies like Amazon and Google. Anybody who has a smart home device that you can say like, "Hey Siri" to or whatever. They're starting to push for this new protocol called Matter, which is built on top of Thread, which is another 2.4 gigahertz protocol. We have support for that. We have reference designs using that along with our Wi-Fi chips as well. We also support ANT Plus from the fitness sort of perspective. And now with this radio, as opposed to our previous generations of radio, you can get up to 4 megabit per second throughput, 2.4 gigahertz. So that's double the speed of our 52 and 53 series radios. So this is sort of the spread you'll see, the sort of applications where you would apply a 54 series part or 54L series part or 54H series part. So the 54H series is pretty beefy. They're all multi-core parts. Excuse me, the 54H20, which has been announced, is a multi-core part. The 54L is actually also a multi-core part. So we see the 54H with its high speed, high power peripherals as being something you use for something where you need a lot of compute with 54L and more like small asset tracking sort of applications where you don't necessarily need a whole lot of computing power. But both of these devices will have basically the same radio. There are some slight differences in receive sensitivity and transmit power, but otherwise the actual speed and capabilities of the radio are the same. So for the 54H, you'd really use it anywhere you needed something on the higher end of the 52 series, or if that wasn't even enough, you'd go for a 54H part or a 5340, which we're using for BLE audio. So 54H is very well suited for BLE audio applications. The 54L, on the other hand, is going to be something that where you would use a 52 series part, you'll slot in a 54L series part and see both performance improvement, significant performance improvement. I'll show you in just a second what that performance improvement looks like, as well as lower power consumption overall. So this is a quick overview, and I'll leave this up for a little while, a quick overview of the 54L and 54H series. So it's interesting to start with 54H just because you see that dual core right there at the very top, 2 Cortex M33s running at up to 320 megahertz. So there is going to be some voltage and frequency scaling capabilities with the 54H. But like the 5340, if you're familiar with that part, there is both a net core with its own bank of memory and an applications core with its own bank of memory. So you can throw your communication stack, whatever it may be, if it's BLE audio, whatever it is, into one core, then have a whole separate core dedicated just to your application. So if you have something with a high throughput requirement or real-time requirement, you'd be able to do that. Also see non-volatile memory. So it's not flash on these parts, since you're not able to you're not able to fab flash at 22 nanometer. So there are a couple of different memory technologies that we're using, and it depends on the foundry being used. 54H20 uses a different memory technology to 54L, but both are very low power. So you'll see 2 megabytes of non-volatile memory on the 54H20 and 1 megabyte of RAM on the 54H20, which is pretty massive. Depending on the package, you'll see 64 GPIO on the 54H20. So we have larger and smaller ball pitches on the packages, and I'll share some information on the package sizes here in a moment. We also have this full suite of peripherals you come to expect on like 52 or 53 series part. So as many SPIs, I2Cs, UARTs as you'd expect. This part actually also has a full real-time clock, as opposed to a real-time counter that you would have encountered on the 52 series of parts. Additionally, with the 54H, we've added some new peripherals, some really cool state-of-the-art sort of stuff. So there's high-speed USB, which is 480 megabytes per second. I think it's megabytes. Correct me if I'm wrong there, but high-speed USB, so significantly faster than the full-speed stuff. There are a couple of I3C controllers on board, which is like the next iteration of I2C, higher data rate. I3C is pretty interesting. There is a mechanism within the new bus to trigger an interrupt with specific codes that are sent over I3C, so you don't have to have a separate interrupt line if you're interfacing with a sensor over I2C. This part will also have CAN FD. So if you're looking at an automotive or industrial application, this might also make sense. Some really interesting forward-thinking stuff we're doing with these parts too, both the 54L and the 54H, is the addition of 2 RISC-V coprocessors, 54H, and 1 RISC-V coprocessor on the 54L. So we foresee that customers will use this to create software-defined peripherals. So you'll use these RISC-V cores to either manage a peripheral on board, so manage a SPI, manage a UART, but you're also able to bit bang whatever protocol you want on this core while still leaving your application core and your radio core totally open to do whatever else you need it to do. So in the 54H, there are 2 of these cores, one's for lower speed peripherals to save more power, and then you have one for higher speed peripherals if you really need that performance. Both parts will be designed for PSA level 3 certification. Then you can see the difference in the radios here. So you'll see 10 dBm transmit power on the 54H. And I think this is the first radio to boast a -100 dBm, cross that barrier, that -100 dBm receive sensitivity. So quickly covering the 54L, this will also have a Cortex N33 on board, 1.5 meg of non-volatile memory, so still quite a lot. 256K of RAM that can also be divided up among the 2 cores on the part, 32 GPIO depending on the package. This won't have the higher speed peripherals you see, like the high-speed USB or CAN FD, but will have full suite of SPIs and UARTs. This will have a RISC-V coprocessor running at the same speed as the application processor, so you could use it to do a quad SPI, maybe like a bit bang, a USB. We'll see what people end up using it for. The characteristics of the radio are a little bit different on this part, so 8 dBm transmit power and -98 dBm receive sensitivity. So yeah, that's big overview of these 2 parts. So as I said previously, these are going to be fabbed at 22 nanometer from something close to double that feature size previously. 54H will be made at Global Foundries in Germany. 54L will be made at TSMC in Taiwan. So that's 2 different foundries, very different areas of the world with very different geopolitical circumstances. So we're trying as hard as we can to be able to diversify our supply chain. So if something were to happen to one fab, it's not like we're totally stopped. We have some path forward with one of our parts. So with 22 nanometer, though, you can expect increased processing performance and efficiency. So you'll have less time where the core actually has to be on, more efficient radio, just because we continue to iterate on that. So lower transmit and receive currents. I think for some parts, you'll see similar receive currents, but transmit currents are lower across the board. And then our new global real-time clock, no longer a real-time counter, can run even in system off mode, which is slightly different from previous chips. So some of the targeted applications you'll see for these parts on the 54L series are like PC accessories, so gaming mice, wireless wireless keyboards, that sort of thing. If you have air quality sensor somewhere in your house, you may use a 54L for that sort of part, and it can use thread and matter over thread to connect back to your Alexa or similar. We'll also see a lot of use, I think, in medical and healthcare, especially in wearable devices. So oxygen sensors, blood pressure cuffs, that sort of thing. Also in industrial IoT for asset tracking applications, for instance, just little tags you may attach to something in a warehouse. 54H, since it's a little beefier, I think you'll see in VR controllers, that sort of thing, maybe smartwatches. Similar applications in smart home. So if you have something that needs a lot of processing power, some sensor in your house that you're adding over Matter, you'll be able to use the 54H for that. Similar, if you're doing a lot of processing or sensor fusion for medical or healthcare applications, you might see that. 54H is well suited for audio because it has the PLLs and other things that you need on board, as well as the separate application and radio core to be able to handle the throughput you need for audio. The CAN FD controller on board will really, it'll mean it's well suited for industrial applications and e-mobility, so things like scooters, bird scooters, something that you're accessing with an app. So we'll do a little bit of a deeper dive into the 54L here. So ARM Cortex-M33 has your main application core, and you have over there in the bottom right corner your little RISC-V core that can chug along maybe while the ARM core is asleep, managing your peripherals. We went over the radio characteristics, so 4th gen radio, 4 megabit PHY as well on the 54L. So Bluetooth as it is now only supports, they support coded PHY, so that's like 125 kilobits per second, 1 megabit per second, and 2 megabit per second PHY. That's all that's supported in BLE. But I think you'll see maybe adoption of this 4 megabit PHY for BLE in the future, or the use of proprietary protocols to really get the throughput of that 4 megabit PHY in use. We see 2 times the processing power with reduced power consumption as compared to the 52840 with using the 54L. Also a lot more non-volatile memory on the 54L. Since it's 22 nanometer, feature sizes are much smaller. The packages are also much smaller. So I will go ahead and move to the next slide, and you can see our smallest package is 2.4 by 2.2 millimeters. So it's quite compact. If you need to fit it somewhere, so long as your PCB fab doesn't complain too much, you really can fit it into most any product. It's very small. And the wafer level chip scale packages, LDL CSPs there on the right, will be available in a couple of different pitches, so 350 micrometer, and you can see that on the left with the little checkerboard. But if you need to access all GPIO, then you would use either the QFN, which I guess it does miss out on one GPIO, but you use the QFN or the finer pitched wafer level chip scale package. Just to show you the peripherals as well, just to call that out. So there are 4 serial peripherals that can be used as a SPI, an I2C, which we call TWI, two-wire interface, or UART. So 4 of those, and then you'll see pins that are recommended to be used for high-speed SPI or UART. So if you need to really crank up the speed on those things, you'll see 2 real-time clocks, 1 global real-time clock that can run in system off, I2S, 2 watchdog timers, 7 timers that can be used globally, NFC tag on the 54L, which is also a feature on the 52840. 2 quadrature decoders, 3 4-channel PWMs, so a maximum of 12 PWM channels, a temperature sensor on board, a comparator and a low power comparator, and now a 14-bit ADC. I think on the 52840, the best we had was 12-bit ADC. So this is also an improvement in that respect. Now we'll go into the 54H, a little bit more specific. So we see the 54H as enabling new IoT products that were not possible before, just because of the huge processing power capability you have with this part and the low power consumption you'll have with this part. So this is world-leading processing efficiency and performance as compared to some of our competitors, and you can check that with our core mark numbers online. They're publicly available for this part now. State-of-the-art security so that we can get through the PSA level 3 certification process, get our customers through that. The same radio, different performance characteristics, but the same radio as the 54L that we discussed. Quite a lot of memory with non-volatile and otherwise, and advanced peripherals. So just to show block diagram, you're talking about a 4-core part here. So that's a core to handle your application, a core to handle whatever radio stack you're running, and then 2 other cores to do with what you want. If you want to shut off those ARM cores and use the RISC-V cores to save as much power as possible, still have something up, you're able to do that. Just run it waiting on an interrupt, also able to do that. But you're talking about a 4-core part in pretty small package. I'll show you that here in a moment as well. So we see this part as being able to replace a lot of different parts from a solution you might have to do in a different way from another competitor. So this is a really powerful microcontroller with no need for external memory for a lot of use cases, with peripherals that sometimes you'd have to break out and communicate to over SPI, as well as a best-in-class radio and the secure element you'd need to get through some of these more stringent certification processes. So I can't share everything about the 54H20. So there's a complete list of peripherals that if you're interested in and want to learn more about, you can get in contact with your regional sales manager or me, and then I could put you in contact with your regional sales manager if you wanted to see more specifics. But you'll see pretty much the same feature set as the 54L and more. So you actually get up to 8 serial peripherals. So 8 that you can define as a SPI, an I2C, or UART. 8 timers, 2 quadrilateral decoders, global real-time clock, NFC tag, up to 16 PWM channels, 14-bit ADC, and more that I cannot tell you about. You'll see high-speed USB, as mentioned before, 480 megabits per second, not megabytes, 480 megabits per second, I3C, and CAN-FD. CAN-FD meaning more than 1 megabit per second on the CAN bus. And the packages are pretty small. 4.7 by 4.3 millimeters on the wafer level chip scale package with all the GPIO broken out, 6.5 by 6.5 on the BGA with all the GPIO broken out. And this is real. There are 54H20 kits in the wild now. There's limited sampling going on right now to key customers, but that sampling is going to open up in the next couple of months. So this is real and available, and people are doing development on it now. The internal development is at a fever pitch right now. So very excited about these parts. So now I was going to share a little bit about Nordic's development environment. Since this is going to be shared across all of our products. So if you've heard of NRF Connect, which is our development environment, which encompasses a lot of things, this is going to be supported on our 54 series parts going forward as well. So there's a whole line of from short range to cellular that we now provide. So you can develop your application to work on almost any of our parts with some configuration differences using NRF Connect SDK. So if you had a project that you were developing on one of our higher end chips, like a 52840 or 5340, and you found that you didn't need that performance, or maybe you do need more performance, it's relatively easy to port your application between different chips. See, Austin asked a question. Yeah, sorry, just before we switch over to software, does anybody have any questions about the 54H or 54L chips?
I'll read Austin's question. And are there vehicle components and other manufacturers working with Nordic for applications of these?
So the 54H with the CAN FD controller is probably, I don't believe, is going to get automotive certification. I expect we'll see more use of the CAN FD controller in industrial IoT sort of applications.
Yeah.
So
yeah, that's kind of what I was asking about. Just given the limitations of some of the existing cans that we see out there, it'd be nice if we could do more in the future, right? So as IoT devices of all kinds are being expanded, and I think we see that really every year that goes by. There's just more application. The CAN itself seems to not go away. So I thought BLE might have done that or something like, but it didn't. It's people need hardwire, so it makes a lot of sense. And so I kind of was thinking about that. And then I saw that you had NRF mesh on the application side. And so they're really kind of not one and the same, but they're potentially related for future applications. So that's why I was curious if other manufacturers or, what kind of interest you guys are getting for those applications.
So it's still pretty early in the 54H, for 54H's life cycle, still not available, still not in mass production. In the Southeast where I am, I haven't encountered a lot of customers. I haven't really encountered any automotive customers. Wes, maybe if you have seen interest in the CAN controller, but I think really what we're going to see is industrial IoT using that CAN controller.
Okay.
your question with respect to NRF mesh, or this is actually BLE mesh. So this is not a Nordic proprietary thing. This is
Oh, okay. All right.
it's
Yeah. So,
multi-channel.
okay. All right. Thank you.
The maximum number of peers, it depends. I think it's been tested to many hundreds of peers in a mesh, but you'll see it a lot in lighting applications. So pretty large buildings that are using BLE mesh successfully. So hundreds of nodes.
Okay.
In mesh.
Yeah. Well, I was curious because mesh is always for IoT devices and applications, nearest neighbors, things like that, routing path, path routing, or reducing chattiness. These are all things that, as the mesh expands, become more difficult to tackle, right? And so I was just kind of curious if there was something that you all were doing that made that more efficient, or had implied scoring for neighbor communication, or something along those lines. Just because I don't see a lot of people overcoming the larger mesh, but several hundred is a good size. That's pretty.
And often you'll see that these applications are not low power applications, especially in consumer and commercial lighting. Commercial lighting is the biggest mesh application, and you have access to mains power with that. What you see with mesh a lot of the time is that your radio is on a lot of the time, either receiving or transmitting. Just it's the nature of mesh. So you don't see it so much in low power applications. And then that's kind of just part of running a mesh network, is that you're going to use a decent amount of power.
You're going to use, the bigger it gets, the more you draw. So, and that's good that you said that. So, thinking of handheld devices, things like that, those often suffer from a lot of different, limitations, just simply because of things like power that you mentioned, stuff like that. I think one of the things I was curious about, following on to this question, I know there's another one in the chat as well, is that when implementing a mesh, is there like a controller peer type topology where it's more one way to achieve a higher degree of power efficiency, right? So if I have bidirectional, right, it's more power requirement than if it's unidirectional. That's my implication.
So I think like a place where you might use BLE mesh and you don't need every peer to communicate with every other peer, I would look at Matter maybe as a
Matter. Yeah. Okay.
Just because you do have those different classes of device. So if you could have one central node somewhere in your house, or somewhere in an office, and then you'll have sleepy end devices that communicate back to the big guy that may have mains power or a larger battery, and structure your network in that way, and maybe get away with longer battery life, just as a possible suggestion.
Yeah, no problem. Yeah, I was thinking around some of those things. I love mesh because I think the applications of it are great, but there, are different limitations depending on what you're doing. So the powered version makes a lot of sense for a building. I was just kind of surprised that it's hundreds, and if it's hundreds, then does that mean it's, is it hardwired versus wireless? And but it's RF, so I'm guessing it's wireless, right? So that's a pretty broad thing. So I'm sorry to sidetrack. I really am interested in that though.
Yeah, happy to answer.
Thank you. I'm going to go to the last question and then I'll go back to Tom's question, but is Nordic support narrowband communication? NB-IoT, narrowband IoT, we do have a part, and we have other parts coming soon that do support NB-IoT, and that's our 91 series of parts. So they're LTE-M and NB-IoT on those parts. So the current device out now is a system in package called the nRF9160. So if you're looking for more information on that, be sure to search up the 9160. We have some other parts coming soon, sort of a refresh of the 9160, 9161, very inventively. That'll be available soon. I think it's sampling now. And then we have some other stuff coming in the future that I cannot share, but we do have cellular NB-IoT parts available now. Awesome, thank you. And then last question that's in the chat is, I'm sure this is an it depends kind of question, but can you give a bit more depth on the battery life trade-off for taking advantage of the additional processing power?
So with these parts, the sleep current on the whole is lower. We find that really a lot of the time, the biggest source of power consumption is radio on time. So as best as you're able to reduce radio on time, the lower power consumption you'll see. With this, I think what you'll see is on the 54H, especially with the dynamic voltage and frequency scaling, is like bursty, like large power consumption and then shut everything off sort of operation. But overall, you should see lower power consumption with these parts as compared to 52 series when you're doing a 52 series sort of workload on the part, if that answers your question. So, yeah. All right, so any other questions on the 54 series, 54H, 54L? I guess I can talk a little bit about the RISC-V effort, since it's like kind of different to see both an ARM core and a RISC-V core in the same part. So we're committed to continuing to use ARM cores. I mean, we have ARM cores in our parts now. We have ARM cores in the 54 series, but we see a lot of benefit in moving into the RISC-V space. So Nordic actually entered into a consortium, started a company, contributed to this company that's going to create RISC-V IP, RISC-V peripheral cores in Europe. So Nordic, along with Infineon, Bosch, some other partners, we're starting to move more into the RISC-V space. So we're leading the charge in that respect. Still using ARM cores, so that's not changing, but definitely starting to open up to the RISC-V wave that's coming. So, but yeah, as a developer, you won't have to worry about that at all, because our wonderful SDK, nRF Connect SDK, will just handle all that for you. So I'll share a little bit about nRF Connect. nRF Connect SDK is a Zephyr RTOS based SDK. So it's Zephyr, if you all are familiar, which Zephyr is very cool, a lot of fun to work with. Zephyr with a couple of extra packages added on. So some of our stuff, some of our proprietary protocols are included, and a lot of other things besides just Zephyr. So trusted firmware M, if you're an IoT security nerd, TFM is available, MCU boot is available, which is part of Zephyr. So if you haven't encountered Zephyr, I heard it described in the comments of a Nordic YouTube video as making simple things more complicated, making complicated things much more simple. So if you have not checked it out, I would take a few hours and look at the Zephyr RTOS and nRF Connect SDK. So it encompasses a lot of things. It's libraries, it's hardware drivers for a lot of chips. If you look in the Zephyr repository, you'll see a lot of different things, kind of going with the monolithic kernel sort of approach, maybe that Linux is using. This is also a Linux Foundation project. Zephyr is. So nRF Connect isn't just the SDK though. We have a lot of different tools that make things easier for the developer. So we have an nRF Connect for desktop app that encompasses all of the things you'll see there. So a toolchain manager to make sure it's easy to install the SDK, to get compiling quickly, some BLE tools. So if you have one of our nRF52840 dongles, which I thought I had on my desk somewhere, but it's a 52840 that you can plug into a USB port, use it as a BLE sniffer, and install this little utility and then add it to Wireshark to see the traffic going on over the air. There's a programmer built into the nRF Connect for desktop app. If you're a cellular developer, our LTE Link Monitor is a really nice tool. I do have the Power Profiler kit, which if you have not encountered yet, if it doesn't blur it out, the Power Profiler kit, which is a very good ammeter down to 100 nanoamp resolution. So there's the application you use to control that in that nRF Connect for Desktop app, as well as a modem trace collector. Our VS Code tools are good. Even if you're just a Zephyr developer, if you're not using nRF Connect SDK specifically, they're still really good tools. So there is a serial terminal added to VS Code through our extension. It makes debugging Nordic parts super easy. You can generate memory reports, and it'll give you a good pie chart visualization of your memory use, which uses a little West utility in the backend. And some pretty cool GUIs to interact with the device tree, which, if you're not familiar, the device tree, which fell out of the Linux project and has been incorporated in Zephyr, is sort of a way to describe the hardware that you're connecting or using with whatever SoC you're using. So you define, let's say, an accelerometer on the SPI bus, this accelerometer specifically, you spell it out in the device tree. So we have a GUI that allows you to interact with the device tree instead of having to parse the arcane things that exist in it. Also, we have a little tool to help you create a new board, which can be a pretty involved process in Zephyr. So we also have a tool that makes that process a little bit easier. Also have a few mobile applications. So I use that nRF Connect for mobile all the time. You can have your phone connect to arbitrary BLE devices pretty simply. We have an nRF Mesh app, so if you want to add or provision a device onto a mesh, you can use it that way. And some other stuff that interacts with like our cloud services. So a few mobile apps that make the development process a little easier as well. So the whole point of this is to support product development from just evaluation down to mass production. So we have a lot of samples. Zephyr has a lot of samples. We specifically have a lot of BLE samples since that's our favorite stuff. So if you've ever used Nordic UART service, there are existing Nordic UART service examples in our SDK. If you've ever looked at our proprietary protocol, enhanced shock burst, which is used in some gaming mice, for instance, we have examples of how to use that as well. We also have full demo applications, I guess you could call them, that show you a wide variety of different samples kind of added all together, looking more like a product. So the device you'll see on the left, that orange box, is the Thingy 91, which is based on our 9160. So that includes GNSS, so GPS, and a couple other constellations, GPS and cellular. So you can use it as an asset tracker, just right out of the box. You can plug up your Thingy 91 and get location. And you can see your house based on cell tower location, GPS, and it'll beam it back up to the cloud. And it's pretty cool, get up and running very quickly. But we support all the way through development of the application and then mass production. So if you're trying to build a product, this SDK is mature. It's great to use, and it has all the services you need to build, program, provision products, real products in the field. We also have complete, verified, and optimized wireless stacks, drivers, and protocols. So if you're trying to do LTE-M, we go through carrier certification. Carrier certification is pretty arduous, but we go through it with pretty much every carrier you can think of all across the world. We have support for NB-IoT, GPS, BLE, ANT. We have Wi-Fi companionships now available in the nRF7 series, so 7002 if you've seen that. We do have some support for Zigbee on the 52 and 53 series, Thread, and Matter. The technologies you'll interact with when using nRF Connect SDK, you can use the command line for a lot of it, but it's pretty easy to get along with VS Code and nRF Connect for Desktop app. Under the hood, an nRF Connect SDK application is based on CMake and Zephyr's kconfig system. So it's based on Zephyr. We also roll in MCU boot and TFM if you need those security services. You'd expect to use Git. All the open source stuff is hosted on GitHub for nRF Connect SDK, CMake, and then the device tree. Our development kits, we have development kits available for all of our parts. So if you're looking at a 52 series product, we have the 52 DK, which is the smaller of the two. I think I have one here. 52 series DK for the 52832, 52840 dev kit. We have USB dongles. We have the Thingy series of prototype kits. So if you're looking to develop with a 5340, it has a number of sensors and a battery on board. So if you need to get a proof of concept rolling quickly, we have the hardware to support that. So this is the wide variety of different parts of different technologies that are all supported by the same SDK. So what's interesting is that you're able to load up an example with minimal changes to your application, minimal changes to the sample application, and get it running on both the 5340, which is a very different architecture from the 52840. And both of those things will work on the same device, or excuse me, from the same application with differences in configuration. So your actual application code, if you need to change from 52832, you need the extra processing power, you need to move to a 52840, you need the extra memory, for instance, you're able to do that very easily and with minimal application changes. So this is sort of the anatomy of an NRF Connect application. So you'll have Nordic applications built on top of, building on top of the shoulders of our connectivity protocols. So our BLE stack, our security libraries like using TFN and MCU boot, all built on top of Zephyr RTOS with their wonderful board configuration features. So the biggest parts of NRF Connect SDK is NRFX lib, which is some things that fell out of the NRF5 SDK, which is bare metal, if anybody is familiar with that. So NRFX lib and NRFX, which is our peripheral drivers for all of our devices. So 52 series, 53 series, 54 series, using those along with Zephyr, MCU boot, these other repositories. It also really aids in the development of Matter application, for instance. So when you're setting up your NRF Connect SDK app, if you need to roll in the Google Matter repositories, they're not Google, I guess, anymore, it's Chip something, the Matter consortium, you can roll that into your application super easily, and we have guides on how to do that. If you want to see it in very specific detail, you could see all the different stacks that are available in Zephyr and NRF Connect. So if you're looking to do cellular stuff, you want to use maybe a low bandwidth protocol like CoAP or MQTT, that's available. We have TLS, UDP, TCP, all the way down the stack as far as you'd like to go. You can see it, it's available. Most of it is open source. So it's really cool to see. You may ask, why Zephyr RTOS? So all of our new products moving forward are going to be using NRF Connect SDK built on Zephyr RTOS. So it's possible, I guess, to do bare metal development on some of these parts, but it's definitely not recommended, not well supported. So we went with Zephyr because it's designed to be a low power, wireless centric sort of RTOS. It's governed by the Linux Foundation, so we don't think it's going to go anywhere anytime soon. And it's contributed to by a number of different players in the industry. So it's not just Nordic. It's not just a Nordic project. You'll see Intel, ST, all kinds of different players also contributing to Zephyr. It's developed with a focus on security. So there are people working for the Zephyr project that are serious about security and working on it all the time. And you'll see through pull requests and the commit history on Zephyr, you'll see the way they handle security incidents. It's very serious, very professional.
There is a question in the chat. Is there any crypto/security at the hardware layer for acceleration, or is that all handled at the runtime app level?
I will say it depends. It depends on the chip you're using. So there is hardware crypto acceleration on the 52 series parts, and that there's an ECB, electronic code book, which is what AES is built on top of. There's a hardware block that does that. So it's not all in the application. It depends on the part though. So the 5340, which is our higher end part, will have a different set of features, and the 54H20 There's some other secret sauce security stuff that is not publicly released yet, but yes, there will be hardware acceleration, and we're moving more toward more hardware acceleration for security moving forward.
Thank you for that.
Yeah. Just a couple more things here with respect to Zephyr. Zephyr, if you don't, why would you re-implement something if it already exists? There are already really good implementations of a feature somewhere. So Zephyr includes a lot of fundamental pieces of code and functionality. And working with an RTOS is a little bit easier. You save yourself having to develop your own scheduler, for instance. But if you need to do something complicated, it's much simpler to be able to have it right there in the SDK without having to go grab a library and incorporate that library. So if you need an HTTP stack, it's right there. If you need a BLE stack, it's right there. If you need TCP or UDP or CoAP or MQTT, it's all right there. It's not something you have to worry about rolling in. It's something that's tested with the RTOS. It's something that's easy to use. It's also very scalable, actually. I know I've had customers who are concerned about memory footprint of using Zephyr, but if you need to make it fit, you're absolutely able to with pretty good feature set of the Zephyr RTOS. So you can get down to 8K of code space running Zephyr RTOS. It's not something that the most resource constrained microcontrollers may be able to handle, but for 9/10 of the projects out there, you'll be able to get it done with Zephyr. So last thing I'll leave it with is Zephyr is a very vibrant community. You see, this is old too, but around 1,500 contributors, really long commit history. Yeah, 3.2 last release when this picture was taken. So it's vibrant. You see the market share of people who are reaching first for Zephyr as opposed to another RTOS grows year on year. I think last year it was like 13%, and surveyed this year it was like 18%. So it's getting there. I'm a big fan of Zephyr. It's a lot of fun to use. Developed examples with, develop real products with. It's a really good environment. There is a learning curve associated with Zephyr, but once you get there, it makes the hard stuff easier. So yeah, that's everything I have on nRF Connect. If anybody
excuse me, Helmut, maybe you want to point out the Developers Academy to help accelerate learning of Zephyr and plus both cellular and/or Bluetooth.
Yes, so Nordic has, and I'll find the link and post it in chat here. We have a course, a series of online courses. Go at your own pace, sort of online courses. At academy.nordicsemi.com, and I'll post that right there. academy.nordicsemi.com, and it runs you through everything. So from the very beginning of getting the SDK set up and compiling down to like how does Zephyr work? How do I use the device tree? How do I spin up another thread? How do I make the thread sleep? Like every part of using Zephyr. In our fundamentals. We have some other courses coming soon that'll be on other topics like Wi-Fi, and then like an intermediate look at how to use Zephyr or nRF Connect SDK. But right now what's available is the intro to nRF SDK, nRF SDK fundamentals, BLE, Bluetooth Low Energy fundamentals, and cellular IoT fundamentals. So those 3 courses are available right now. If you're interested in Zephyr and want to poke around, so long as you have a 52 series dev kit or a 52840 dev kit, you can get started very quickly. The actual installation of the SDK as compared to previous, maybe like the nRF5 SDK, is much easier. You can get up and running, have a demo flashed on a board in like 20 to 30 minutes from scratch. So it's awesome. So yeah, I would take a look if you're at all interested, academy.nordicsemi.com, and run through at least the SDK fundamentals, nRF Connect fundamentals. So.
Well, thank you very much for that presentation. We'll now take any questions from the audience. If you guys have any, please place them in the chat box and I can read them out loud. No questions? That's a sign of an excellent presentation.
Got them all already.
Yeah, absolutely. Well, I mean, if no one has any questions, Helmut and Wes, what's the best way for folks to get in contact with you if they have any questions later on?
So you can contact me at k.helmut.lord@nordicsemi.com. I'll go ahead and post that in the chat. Sorry, I'm not sure if you can hear that. Cat's going crazy. One second.
I'll get that in the chat for you.
You can contact me there, k.helmut.lord@nordicsemi.no. I'm in the Southeast, so if you're in the Southeast, I can get your questions answered. Of course, if you're anywhere else, you can also contact me, and I can make sure that you get help no matter what. I'm not just gonna kick you to the curb. So, but yeah, I'll direct you wherever you need to go. If you need to talk to a regional sales manager, if you need to talk to a field application engineer, I can make sure you get into contact with who you need to. So.
I do have one other question, so I apologize.
Go
I
ahead.
saw there wasn't a lot of others, but one thing just came to mind. And that was, I missed the first few minutes. In the industry that you guys are in, what are the main differentiators between Nordic and some of the others that might be out there? Are you mainly focused on smaller, scale chips for larger applications? So, scaling, like you mentioned, like field service type things and devices out in the field and things like that. Where's Nordic positioned in the industry?
So you'll see us in all kinds of different industries. I know in the Southeast, I encounter a lot of asset tracking. So asset tracking, flush valves, industrial lighting, consumer lighting, the Matter sort of smart home space. But Nordic's like claim to fame, our big thing is low power. It's always been low power use. So anywhere where you see something that needs to run on a coin cell for a period of years, you got a good shot of finding a Nordic part, and we're industry leading in that respect. So
Gotcha.
for applications where you need BLE connectivity and you need something to run for years, you're probably better served. I like to think. Probably better served.
Kind of like an Air Things, that kind of stuff where, now their cells are much bigger. I don't know if you're familiar with Air Things, but, it's essentially like, environmental monitoring, right? And so just being able to, sniff the air, find radon, those sorts of things. But you're suggesting those take double cells. So something that is going to last for much longer with a much lower power requirement, that's where Nordic would be.
Yeah, and anywhere where you need to stretch your battery life, or where you think where you see, oh, I need a 1,000 milliamp hours for this project if I use this manufacturer because I have a requirement that it needs to last for a few years. You can cut the size of your battery in half, maybe more, and you save not just in the size of the battery. You're able to get a cheaper battery, but you save in mechanical footprint. All kinds of respects. So it's not just that it's lower power, it's that it enables other things by being lower power.
Of course, yeah. Thank you so much.
Yeah, and just to add to what Helmut was speaking to, so Bluetooth Low Energy is our main. We constantly sort of mention that, and the reason we'll mention that is we're like 41% of the global market of Bluetooth Low Energy. So any wireless replacement needs an extreme low power in an embedded environment is really our target environment, right? Whether it's consumer electronics or we are in some industrial and commercial type things, but just to give you an idea.
Yeah, thank you so much for that. I apologize for being late to kind of hear what you guys were all about, but I've liked what I've heard so far. Thank you.
No, thank you for the question. No.
Awesome. Well, that's all the questions that I'm seeing. Thank you all so much for a wonderful presentation. As a reminder, Riot hosts these Lunch and Learns weekly on Wednesdays at 1 p.m. Eastern Time, and you can find a list of our upcoming Lunch and Learns on Riot's website and our meetup groups. This event was recorded and will be posted to Riot's YouTube channel. Thank you all for joining today, and I hope that everyone has a great rest of their day.
Thank you.
Thank you. Bye.
See ya.